So in section 3.5, we look at some higher degree polynomials, so maybe some degree 3, 4, 5 polynomials. And these are several questions that you might be asked. Unlikely you'd be asked all of them for one problem. Okay. But for these polynomial functions, you want to be able to do domain and range, find any max and min, intercepts, and then also get increasing and decreasing intervals. Okay. Again, right now we're only looking at polynomial functions, which nice then is that the domain is always all real numbers. For polynomial functions, there's never any value of x that you could not plug in. So the domain is sort of a gimme. It's always going to be all real numbers. Okay. Then we start looking, and remember, you can only do max, min, and intercepts sometimes with the calculator. So that's what I want to show you here. Okay. We know that in general, polynomials will just go up and down for a while. They're smooth, they're continuous. Okay. And then the ends head off to infinity or negative infinity. Okay, so this might be an example where they go in two different directions. You might have something where it goes up and down for a little while, and both ends maybe go up. Okay, we've talked about sort of that long-range behavior and knowing which way the ends should go, and so we'll also see that. Okay, the thing to remember, right, for x-intercepts, the most you can have is what matches the degree. For max min, the most you could have is one less than the degree. Okay. But let's just work a little bit on finding a good window and finding a few of these, a few answers to some of these questions. Okay, so we're going to start with this degree 3. So we have negative 3x cubed plus 6x squared plus 39x minus 60. Okay. So just as an aside here, again, the domain we already know is all real numbers. In this problem, we could actually answer the range right away. Okay. We know for degree 3, let's sketch something down here, right? The ends have to go in opposite directions. Okay. Since it's a negative leading coefficient, the left end goes up, the right end goes down. Okay. So the only thing we need to sort of fill in is what can happen. And again, it can only turn around twice. Okay. So there could be 3x intercepts. There might only be one. Okay. So keep in mind if it looks something like this, we only have one x-intercept, okay, but it could have 3, could also have 2, okay, and at most 2 turnaround points, okay, but we can see since the ends go in opposite directions that the range is all real numbers. Okay. So let's look at our calculator and see if we can figure out how many max min there will be and how many x-intercepts. So we clear out all this. Alright, so we have negative 3x cubed plus 6x squared plus 39x minus 60. Always a good idea to double check that it is typed in correctly before you get started. Okay, now again, I'm going to hit zoom 6, which is unlikely to be a very good window. Okay. Again, I can see sort of 3 parts here, okay, and I'm going to just have it graphed again. Okay, you see it come down, shoot back up, and then come back down again. So I already can sort of see what's happening here, even though I don't have a very good window. Okay, but because I know it's a degree 3 and I already kind of sketched what might happen here, okay, I can see what in fact did happen is it came down, it went below the axis, then it went up, and then it came back down. So I'm going to be looking for this max and min and 3x intercepts. Okay. Again, I'm going to do maybe a slightly better window. Okay. Polynomials do tend to go up and down fairly quickly. Okay. So the y's tend to need to be a little bit more. So this is kind of rough guesswork. So I'm just going to go negative 100 to 100. Count by 50s. Everything seemed to be happening here, so I think we're okay. And you can see I'm in pretty good shape. I know I can't be missing anything. If it's a degree 3, there can only be at most 2 turnarounds, and I can see them both. For a degree 3, there's at most 3 zeros, and I can see them all. So I'm all set to go. Okay. So we won't find all of these, but let's do the max and the min. So the minimum is down here, so we're going to second calculate. We have to go left of it. We have to go right of it. And then we make our guess. So we have a minimum at negative 1.5 comma negative 94.9. Alright, let's do our maximum. So here we are left of it. Take any of these. I'll just go about right there. I have to go right past it. And then make my guess. So my max is here at 2.9 comma 30.4. Okay. I'll come back and get a couple zeros in a second, but let me just show you then, we can do our intervals of increasing, decreasing. So again, this is just a rough sketch of it. It goes down until we hit this minimum, which we found. It goes up for this little piece till here, and then it goes down. So again, it starts out decreasing. It decreases until we hit here. So everywhere from negative infinity until this x value, right, which was negative 1.5. And then it starts decreasing again after the maximum. It increases just on this one little part right there. So from negative 1.5 to 2.9. Remember, these are all x values. Okay. And then again, for the intercepts, remember for the y-intercept, you're just plugging in 0. So you can actually just do the value, plug in 0. So you get negative 60. So for a y-intercept, you get 0 comma negative 60. For x-intercepts, remember you have to find out when is 0. And again, we can see 3 places. I'll just find this first one to the left. So again, we're calculating zeros now. X-intercepts are the zeros. So I have to go left of it. So let me arrow back here. Go right of it. And it moves quickly. And then I make my guess. So one x-intercept is at negative 3.4 comma 0. And then there's 2 more. I'll leave those for you to find. Okay. All right, let's look at a degree 4 here. See if we can get a decent window for this one. So let's clear this out. Let's take 3x to the 4th minus 33x squared plus 54. Again, zoom 6 is probably not very helpful. Okay, but again, I can see a lot, and I should know before I hit graph, right, that this is a degree 4 with a positive leading coefficient. So I already know the ends should both be going up. Okay. Now, a few things could happen. It could just turn around once. It can't turn around twice because then it just goes down. Okay, so the most that can happen is turn around 3 times. Okay. And again, at most, you might have 4 x-intercepts. Okay. That's certainly what it looks like from our graph. So again, if you just think it's going to start up here, wiggle up and down and go back up, then this does make a little bit more sense when you watch the graph. So it comes down, goes back up, comes down, goes back up. Okay, so again, there are 4 x-intercepts. Okay, keep in mind another possibility. This is not what happened in this problem. If it's a degree 4, it could just turn around once. It could turn around like I'm showing it, but never hit the x-axis. So it's possible to have no x-intercepts. Okay. Notice in either case, since the ends both go up, this is a restricted range. Okay. We're only going to go down so far, and then so our range will be from that y value all the way up to infinity. Okay. Let's get a better window so we can kind of see what's happening here, so we can see these 3 turnaround points. Again, my x values are good. I'm actually going to get rid of some over here and over here, but the y values need to go much higher and lower. So I'm just going to go negative 5 to 5. Everything seems to be happening between there. And again, it's just kind of guesswork. 33 and 54 are pretty big numbers, so I'm going to go negative 1,000 to 1,000. Okay, so again, I'm going to count by 500s. Oh, and I actually probably did too much. I have all this dead space here. Okay, so I'm going to move this up a little bit. But I'm starting to see it a little bit better. So maybe, I definitely don't need to go down to negative 1,000. So maybe I should just go, let's go negative 200. And I'll just make that 500. It's definitely starting to look a little bit better. Okay, so I think we can see what we need to see here. Okay, I'm going to find these, there's a min, max, and a min. I'm going to find the minimums. Okay. So again, my domain, that's a freebie. For polynomials, it's always all real numbers. I'm going to hold off on this. I'm going to get my 2 min. There is a max. I may leave that to you to find. But let's look at these 2 minimum. So again, second calculate number 3. Let's go back here left of this one. Hit enter. Right of it. Hit enter. One more. So one of the minimums is negative 2.3, comma negative 36.75. Repeat that for the other one. Go way over to the other minimum. I'm going to stay left of it. Hit enter. Go right past it. Hit enter. Take a guess. Another one is 2.3 comma negative 36.75. So it's sort of interesting that there might be some symmetry here. Okay, it is probably worth your time to check. This is an even function, so there is symmetry. Okay, again, I'll leave you to find the max. Okay, but this tells me my range, so I now know in my picture the lowest I go is negative 36.75. I hit that and then I go up. Whoop, sorry, that should be up here. That's my range. The lowest the y value, remember we range our y values, the lowest, the minimum was negative 36.75, and then I go up to infinity. Okay. So let's just do our increasing, decreasing. Actually, I'll need the max. So let me get my max real quick here. So second calculate. Max appears to be at 0, but we'll double check. So I go a little bit left, right, and my max one is in fact 0.54. Okay, and so for my increasing, decreasing intervals, so I'm running out of room here. Again, I can see that it goes up in 2 places. It goes up here, and then it goes up at the end. So starting at this minimum, which remember was at negative 2.3, till the max, which is at 0, and then after the second minimum, it starts to go up and continues to go up forever. Okay. For decreasing, right, it's decreasing until you get to the first minimum. So from negative infinity until the first minimum, which is at negative 2.3. It also decreases this little piece right here, from the max to the second min. From the max, which was at x equals 0, to my second min, which is at 2.3. Okay. Remember, increasing, decreasing intervals are always x intervals. Okay, just one more here, and this one we'll probably just work on the window. All right, so again, I have a degree 3. It's a positive leading coefficient, so already I know it starts down here, winds up there. Okay, it could turn around. It has to cross the x-axis, so it could look like this. Okay, it doesn't necessarily have to turn around, so it could just keep going up. Okay, it could come when it turns around. It might come back and hit the x-axis. So again, a few possibilities, but I know the ends should be in opposite directions. Okay. Here I'm asking for how many turnaround points, so maybe that's the only thing I'm really interested in here. So let's get this. X cubed minus 2x squared minus 2x squared. This up here. Let's try that again. X cubed, go out of that, minus 2x squared plus x minus 2. So again, I'm going to start with zoom 6. Might not be the best. But I see it, and and a lot of it is what I expected it to be. Down, bottom left to start, finish top right. What is interesting about this one is this part right in the middle. I'm not sure how well you can see it. You could put in your calculator, but it seems to be going almost straight across. Now again, our calculator can only be so precise. We know polynomial functions do not go straight across. Okay, so we don't know if it's just going up very slowly at that point, in that interval there, or if it's turning around, going down a little bit and coming back up, but you can't see it. So you're gonna have to zoom in on this little piece to see if it's turning around or not. Okay, but we do know it can't be going straight across. Okay. Now we could try to zoom in. I'll show you that first. So you hit zoom in. Now notice when you zoom in, nothing happened. You have to see your cursor. So if you use your arrow keys, you'll see the cursor because you have to tell the calculator where you want it to zoom in towards. So I would put that right, near the area in question here and hit enter. And now we're starting to see, yes, maybe it goes up and then down. And there's 2 turnaround points right there. Okay. Now sometimes when you keep zooming in, it doesn't quite work so well. Okay, so let me just give you another option that might work. Zoom box lets you pick exactly where you want to zoom in. So I'm just going to show you that. So you give it the box that you want to magnify. Now again, there's a cursor here. Okay, you have to make a box out of the cursor. So I want to see, this is sort of the top left part of the box. And then you notice I hit enter, sorry. Then when I pull it down, it's now, and go to the right, it's starting to form a box. And it's just going to show me what's in the box here in a much bigger way. Okay. So if I hit enter, again, I can see it more clearly. Okay. Zoom box is kind of a nice one. When you zoom in, you don't get to control the horizontal and the vertical. It just zooms in the same amount each direction. Okay, zoom box lets you do something a little bit nicer. So let me just show you that one more time. So I'm going to start back at zoom 6. And again, this was the piece I wanted to zoom in on. So again, for zoom box, just hit enter. You want the cursor, you put the cursor at the top left corner of where you're interested in. So I'm going to put it about right there. Go up a little bit, hit enter. And then again, once you hit enter and you start moving the cursor again, it forms the box. Okay. Hit enter when you're done. And again, you get a pretty nice picture of the zoom in. So there are 2 turnaround points there, and you would need to find that max and the min. Okay. Again, just back to zoom 6 real quick. We can also see clearly there's only one x-intercept.